So, welcome as we continue with our discussion of belief and knowledge, doubt and uncertainty, and a pleasure to welcome Dr. Stuart Firestein. And I found Stuart, because I had read his book that he mentioned, Ignorance, How It Drives Science, and I saw this book, and first of all, it looked very accessible, which was very good. A lot of science books are very, very hard to get through, and this, I looked at it like, this looks really interesting. So I read it, and I decided I was going to use it as the inspiration for a Yom Kippur sermon, based on a text from the Talmud that says, teach your tongue to say, I don't know. And so I read it, I loved it. I sent Stuart an email, and I said, I love your book. I'm using it for my Yom Kippur sermon. We had lunch a couple years ago, and he is here just for a few days. He's coming back from England and is taking his time to be able to be with us. So Dr. Stuart Firestein is the former chair of the Columbia University's Department of Biological Sciences, where he and his colleagues study the vertebrate olfactory system, possibly the best chemical detector on the face of the planet. His laboratory seeks to answer that fundamental human question, how do I smell? So I hope everyone showered this morning. Dedicated to promoting the accessibility of science to a public audience, Stuart serves as an advisor for the Alfred P. Sloan Foundation's program for the public understanding of science. Recently, he was awarded the 2011 Lenfest Distinguished Columbia Faculty Award for Excellence in Scholarship and Teaching. His book on the workings of science for a general audience, called Ignorance, How It Drives Science, was released by Oxford University Press in 2012, and actually became the inspiration for a TED Talk in 2013, and as of yesterday, it had, I think, 1.2 million views. So,
really bizarre.
So please join with me in welcoming Dr. Stuart Firestein.
I don't even have that many friends and family, so I have no idea where that comes from. It's more miles than I have, which is I'd rather have miles if I could trade them in for miles. That should be a place for that. I have less well-prepared remarks because I want this to be a discussion, but I'm going to bring up a couple of points that I'd like to see us discuss at these sort of crossroads, the science and religious thinking crossroads. So I'll just start with 4 words, I guess, which I think are crucial. Ignorance, doubt, uncertainty, failure. And the key thing is that in science, and I think in religion, we do all 4 of those things, and the result is not despair, which is what one might think should be the result of worrying about ignorance, doubt, uncertainty, and failure. And so I'm interested in how come it isn't that leads to despair, what it is we do differently that lets us go down that road, which is a far more interesting road than the road of certainty and pure knowledge, or thinking you know something, or any of those other kinds of things, and over-worrying about success and not taking enough account of failure as a good. So how do we see those things as goods rather than as evils, if you will, or bads, in science, and I think to a large extent in religion. So I think that's one of the places where there's more commonality than we might have expected. What I find in science, so I'll talk about it in science for a moment first. What I find in science is that we currently, to the credit of many scientists, and many whom I work with the Sloan Foundation, there's an interest in making science more accessible to the public. The Cosmos series, for example, and the kind of work that Heather does and all the rest of that. So, and I'm all for these things, Brian Greene's World Science Foundation, Science University, and many of these things. But I also think they leave something fundamental out, which is what I'm trying to be concerned with. So in the end, I think you can only make science so accessible to people who are not well-trained as scientists. I mean, I'm a biologist, and I'm only going to understand a certain amount of quantum mechanics if I'm lucky and work really hard at it. And most of it will be in the form of metaphor, not the actual equations. Most of it will be in the form of narrative, not the actual experiments, and so forth and so on. And so in the end, it will always be a bit watered down. That's not awful. I mean, it's a fascinating story. There are really interesting things to think about with it, and I do think having access to it is kind of nice, and I appreciate scientists who are willing to do that. But I don't think fundamentally that's what we want to teach the public about science. And in a way, I think that this is where religion can help science do this. I think the problem is that the ideas of ignorance, uncertainty, doubt, and failure belong to the elite professional scientist and are so implicit in everything we do that we forget to make it explicit, giving off instead a sense of, we know what we're talking about, we know what we're doing, we have the answers. Sometimes even though we know we don't, when we feel forced to do so, sometimes we with hubris do so when we don't anyway, and aren't being forced to do so, but do it. But I think, so what I see, of course, is in the educational system, and in the end this all comes back to an educational system, I suppose. What I see in an educational system is that we have, I don't know, all the kids in second grade, the girls and the boys love science. They want to do experiments, they want to play in the dirt, they want to look at things through the microscope, they want to talk about insects and see what goes on with them. They go to science museums, they run around, they love science, they're curious. By the 11th grade, fewer than 5% of the students want anything to do with science, let alone a career in science, which doesn't worry me so much. That's it. Well, there is this side issue of, we're not producing enough scientists. The STEM, so-called STEM subjects, science, technology, engineering, and math. Yeah, I always forget engineering. That's my colleagues love that.
And now it's STEAM with
yes,
art.
art in it as well. So I'm actually not worried about whether we're producing enough scientists or not, just to get that rant out of the way. I think we could produce plenty of very fine scientists, we always have. There's a very simple solution if you think we don't have enough scientists, and that's an economic and market solution. Pay them what they're worth, put some grant money out there for them to do their work, and people will flock to science. If you don't do that, they'll go into something else that they can make a living at. So that's just the way that goes. I mean, the current age at which, the average age at which a person gets their first NIH grant is today 42 years old. That's ludicrous. You can't have a family. So you have to make that decision. At 20 years old, you have to say, well, I'm not going to have a family, I'll go into science, because you won't have a position that gives you the, anyway, I don't have to go into all that. So, but I'm more worried in a way about the people who are not going to be scientists, about the 95% of those 11th graders who have now become completely disengaged. We clearly have this educational system that's maximally efficient at disengaging the largest number of people possible from the scientific enterprise that really is one of the more, one of the more characteristic features of our culture. So this can't be what we want, but it's what we have somehow or another. And as the geneticists say, you always get what you select for. And that's a warning. That's meant to be a warning. So clearly we're selecting for it in some way. We're selecting for it, I think, at least in part by what I call the bulimic model of education, in which we take a pile of facts and jam it down the kids' throats, and then they go over here and puke it up on some exam, and then they move on to the next unit with no appreciable gain whatsoever, or any need to remember any of it. So this is clearly a kind of a problem, it seems to me, and it's a problem that can be. So, all right, so we take everybody all the way up through, in fact, college, undergraduate, with this kind of a method. And then those few kids who go on to become scientists, who go on to science, they get into graduate school. And from the moment they get into graduate school, everything changes. What you know is not important. What you don't know is what's important. How you frame a question is what's important. How you discover a question. What you do, I mean, this idea of discover, the word discover meaning to remove a cover from something that's there, to reveal somehow or another. So all of these things are important. Understanding uncertainty, understanding doubt, understanding failure, God knows, because most of what you do as a graduate student is fail, and fail again. And that's the idea. Science, I think, can be believed to the extent that it can be believed because its failure rate is so high. So it's important to maintain this extremely high failure rate. That's what gives science its integrity, in my opinion. So, but this is precisely the moment, this point at which some kids go off and do graduate school in science and become scientists. This is precisely the moment we leave everybody else in the world behind with a view of science that is essentially that of a gigantic textbook. A huge accumulation of facts that is generally impregnable without a tremendous amount of work. And I think nothing could in fact be further from the truth. You can get into the game of science, you can enjoy science, you can take great pleasure in it by understanding that unsettled science is not unsound science, which is another way to say what Carl said earlier, that science progresses by being unsettled, in fact. And to make that category mistake that unsettled is unsound is one of the biggest, I think, problems for science today. And I'm talking about science because I'm a scientist, but I hope you understand that I believe that this is all true in the religious world as well. I mean, everything I'm saying, and in the world of the arts as well, in many ways. So, let me point out two quick examples. One is, I'm going to use the cell phone thing. Actually, I'm going to use your GPS device. So a GPS device is actually quite interesting because it exists simultaneously, unknown to most people, in three completely different regimes of science. So a GPS device, because it uses a satellite, which is floating around up there in low gravity, requires Einstein's relativistic physics in order to readjust its clock. Otherwise, it would be off by 50 or so meters, because clocks run slower in a lower gravity field, okay? Run slower or faster? I can never get that straight. They run slower in low gravity. So they run slower in low gravity, and so you have to use Einstein's relativistic equations in order to correct the clocks on the satellite so that your GPS device works. In order to launch those satellites into orbit, you use Newtonian physics. So that's how you get the satellite up there. And then we use them in basically a flat Earth kind of, you know. So you can be in the flat Earth world, you can be in Newton's world, you can be in Einstein's world all at once using your GPS device. And it's important to note that's how science kind of works. It can take from all three of those regimes what works in them and not worry. See, it knows. Oh, I have to take this. Do you mind? Just kidding. Sorry. Let me finish with a story about I. Rabi, who's a famous physicist in the 1960s. Yes, you know the story? Okay. So, Rabi won a Nobel Prize for the development of NMR, nuclear magnetic resonance, and understanding the structure of molecules and so forth. He was a Columbia physics professor, and famously liked to tell the story of when he was a child, an immigrant growing up in the Lower East Side, and he would come home from school, and all the other kids' mothers would ask their sons and daughters, so what did you learn in school today? And Rabi's mother would say, so Isidore, did you ask any good questions today? Isidore won the Nobel Prize. So that's what I think we need to do today, is ask some good questions. Thanks.
Thank you very much.